want to talk about a new topic called permutations and combinations. These are two different things that help us with counting, but I want to start off with an example that we really already know how to do. All three parts here. I want to consider a club with 5 members. Let's just say the 5 members are Alan, Barbara, Catherine, Dan, and Erica. Now, question number 1, in how many ways can these 5 members line up for a picture? So if we want to line all 5 of these folks up for a picture and rearrange them, how many possible ways can this be done? Second question, how many ways can the club, the 5-member club, select a president, a vice president, and a secretary? So be thinking about how to do these things. And then the third question, how many ways can the club select a 3-person committee? When you're thinking about these 3 questions, think about how they relate to each other, how the calculations might be in common, and what might be different about the calculations. And we're going to address these one at a time throughout the video. And so first, let's, of course, handle question number 1. In how many ways can these 5 members line up for a picture? Now, if we use the method that we learned in the last section, we think about this as 5 separate tasks, because we've got to think about, we've got this picture, say we're lining up against a brick wall. The first person in line is like the first task. The second person is the second task. The third person is the third task. You get the picture all the way down to the 5th person. So how many ways can we line up the first person or select the first person? Well, there's 5 people to pick from, right? Now, for the second position, you don't have 5 people to pick from anymore because you've already picked one of those people. And then you have 4. And then, of course, you've used up 2 people now and you have 3. Now you've used up 3 people and there's 2 remaining. And then there's that 1 person left that must go in the rightmost position. You with me? Now, we talked about in the last section that the notation for this is 5 factorial. So instead of writing 5 times 4 times 3 times 2 times 1, it's 5 factorial. And that whole section was about arranging. And if you ever want to arrange anything, then the factorial is the way to go. Now let's look at our second question. In how many ways can the club select a president, vice president, and secretary? So the questions we should be asking ourselves is, can we reuse whatever it is we're trying to count? And a new question is going to be, does the order matter when we get finished with this? So in how many ways can we select club president, vice president, secretary? If you'll notice, that is 3 tasks, right? We have the president, the vice president, and the secretary task. So the president, how many ways can we pick the president? Well, how many people do we have in our club? 5. Now we use up one of those 5 people, and now we have 4 people remaining in our club for vice president. And then once we use up 2 of those people for the president and vice president positions, we have 3 people remaining. And when we multiply, remember the multiplication principle, we're supposed to multiply these values together. 5 times 4 is 20. 20 times 3 is 60 possible ways to select a president, vice president, and secretary. So there we go. 5 times 4 times 3, of course, that equals to 60. I probably should have typed that after that, but I'm focusing in on the calculation and how to do it. Now, this brings us to a new idea. I would like to attempt to write this in formula form, because this happens so often that we have a group of so many and we need to select just some of them. Okay, and that's what we're doing here. We have 5 people and we're selecting 3 of them for positions. Okay, now watch this calculation. I would like to use the factorial symbols. So notice I've got 5 times 4 times 3. Now if I wanted to say 5 factorial, I couldn't here, right? Because it doesn't go all the way down. It doesn't include the 2 times 1. Now I'm going to put the 2 times 1 there. But, that's like multiplying my whole answer by 2. That'd be 120. That's not allowed. So I'm also going to divide by the 2 times 1. So this is a little trick. Now, this is equivalent to 60. Because if I take 5 times 4 times 3 times 2 times 1 and divide it by 2 times 1, really the 2 times 1 is just gone. Now, if I write that in factorial notation, watch what happens. This is equivalent to 5 factorial in the numerator and 2 factorial in the denominator. Now, how does that relate to the question that I asked? Well, if you'll notice on top is how many we have to choose from, okay? So we have 5 people we're choosing from. Now, the bottom, the 2 factorial, that doesn't seem to be in our problem at all, because we were picking 3 people, not 2 people, right? Well, it turns out these are the ones we didn't pick. And what I can do is I can write this as the number of people we're choosing from minus the number of people we're choosing. You catch that? Because this choosing from was 5. And we're choosing 3, and that's what gave us the 2 factorial was 5 minus 3. Okay, now it's going to get easier, I promise. What this is called is a permutation. P-R-M-U-T-A-T-I-O-N, a permutation. Now the notation we're going to use for this is a big P for permutation. How convenient. And then there's going to be these little subscript letters on each side. And on the left side is going to be a 5, okay, to represent how many you're choosing from. And on the right side is how many you're choosing. So every time you write this, you're going to write a big P, and on the left side is how many you're choosing from, and on the right is how many you're choosing. Now, in formula form, I'm going to show you what this looks like. There it is. So the number of permutations or arrangements of indistinct things taken r at a time when r is less than or equal to n can be calculated. Now notice what we got going on here. Okay, so the n is how many you have to choose from on the left. The r is how many you're choosing on the right. And the numerator is n factorial. And then the denominator is going to be n minus r factorial. Because remember, we had the 2 times 1 in the bottom. So we're going to play around with this formula for a little while, and then we're going to use it for particular problems. But what's really important, and I'm going to revisit this several times, is the idea that this is for arrangements right here. So if order matters, and I'm going to say this again so many times you're going to get sick of it, but order matters for this particular formula. If we go back and look at our problem we just did, okay, and notice I forgot the factorial right here. If you're copying notes, I should have put a factorial after these parentheses. But when we pick a president, vice president, and secretary, those 3 people, the order matters. So for instance, if the president is Barbara, and the vice president is Catherine, and Dan is the secretary, that set of officers. So for instance, well, we got it right. That's a different set of officers if I rearrange the names. So when we go back to our formula here for permutation, the order matters that we're doing this in. And again, I'm going to ask this so many times that you're sick of me asking. But let's do some of these examples. Okay, so let's just play around with the formula first and then apply that to some problems. So our very first problem here, you'll notice it says 5p3. Now, how would I read that really? A permutation with 5 choose 3. So notice the first number is what we call n. When I'm looking at my formula up here, the 5 is going to go in the n position. The 5 is going to go in this n position. We're choosing 3, so the 3 goes in the r position. So first, just where does everything go? Okay, so this is equal to 5 factorial over parentheses important 5 minus 3 factorial. So just make sure you can fill it in. Again, the value on the left is how many you're choosing from. The value on the right is how many you're choosing. And it will go in this way every time. Also, the number on the left should always be bigger than the number on the right, right? If you have 10 things to choose from, you can't choose 12 of them. You see what I mean? Always has to be this way. Now, simplification, I have 5 factorial in the numerator. Notice the 5 minus 3 gives me 2 factorial in the denominator. This is exactly the problem we just did. right? We had 5 people in our club. We want to choose 3 of them, where the order they're arranged in does matter. Now I need to simplify this using the rules that we did in the last section. 5 factorial, I'm going to write it all the way down to the factorial in the denominator. So 5 times 4 times 3 times 2 factorial divided by 2 factorial. The 2's cancel. And there's my original problem. 5 times 4 times 3 gives me 60. Now let's try this again. You may want to pause the video and try the second question on your own. But when I fill this in, the 10 goes first, 10 factorial, and in the denominator I subtract the 2, 10 minus 8 factorial. See, it's that simple. And then you need to do your subtraction next, 10 factorial over, we know 10 minus 8 is 2 factorial. And then I write the top one down to the bottom one. Now this would have been better if I picked a smaller number to go over here, right? But we got to do it. So it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial divided by 2 factorial. The 2 factorials cancel, and then there I am ready to plug that in my calculator. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. Let me tell you what I get. All right, provided I type that in right, I got 1,000,000, can't get my wonder right, 814,400. Ooh, there's lots of ways that if you have 10 things to choose from and you pick 8 of them, lots of answers there. And as you can imagine, there ought to be a lot of answers there. And by now I know you've got it, but just in case, I've got one more to practice with, and then we'll apply this to some problems. But I do want to talk about calculator situation before we move on. So now, what does this mean? We have a permutation. So what does that mean? 2 things. Whenever you're using a permutation for a problem, that means you're not reusing whatever it is you have to choose from. It also means that the order matters in what you have to choose from. So you're arranging. Again, for instance, a secretary, a vice president, and a president, a set of officers, is always going to be an arrangement, because if you change those names up, you have a different group of officers. So 6 factorial, remember the first number goes in the numerator. Okay, and the denominator is subtract the 2. So 6 minus 6 factorial. Okay, now 6 factorial stays on top. 6 minus 6 is 0 factorial. Now you may recall, and I should have done this in a different color. How about purple like I'm supposed to? You may recall that 0 factorial by definition is 1, not 0. Okay, so this is one reason, because we're not allowed to divide by 0. We know the answer is not undefined. There's an exact way to do this, and so 0 factorial is 1. So really this is just 6 factorial as my answer, so I need to calculate that in my calculator. So once again, I'm going to multiply 6 times 5 times 4 times 3 times 2 times 1, and just make sure I don't miss any of the buttons, and I got 720. So there's 721 ways to take 6 things and choose 6 of them. It's no different for getting lining 6 people up in a picture. That's exactly how many ways that you could do that. Now let's talk about this in terms of a calculator. Wouldn't it be easier or faster or more accurate if we just had a button in our calculator that we could push that would calculate a permutation for us? It turns out for many calculators there is. Of course, I can't show you how to use every single calculator, but I can show you the ones that I use most often in my classes. Now, what if we want to use a calculator? Remember, I talked about that just a second ago. So what could we do? Well, let me show you a picture of my calculator right here. And I've already pushed a button. And the button that I have already pushed is the probability button. So if you'll notice right here, that guy right there is my probability button. And when you push that, what happens is this listing comes up. And look, there's your factorial button right there. If you want to know what 500 factorial is, by the way, your calculator is going to bark at you because that is so large. But let's say more practically, you want to know 5 factorial. You hit 5, then you hit your probability button, and then you scroll over using this arrow key right here to the factorial symbol. Okay, that's what you would do if you just wanted 5 factorial. Now, I don't want to do all that. What I want is I want to calculate, let's just do this one over here, the one we just did. So we're doing the permutation of 6, choose 6. Okay, now the first thing that I type in to get to where I am now is the 6. So I hit 6, then I hit my probability button, and then this is what shows up. And then the next thing I'm going to do is hit enter. Okay, so again, I hit the 6, right in the order this is written. Then I hit the probability button, and I scroll over to the one I want. Notice we haven't talked about this thing right here, so that's not on the plate just yet. So right now, there's my erase button. Okay, so right now, this is what we're working with, which is a permutation. So I hit 6, probability button. It's already on, underlined, the permutation, so I hit enter. And then I'm going to type in that 6, and let me show you what happens. So the next picture, notice I have the 6 already typed in. Again, let me remind you, I hit the probability button. My pens are really making me mad today. Okay, I hit the probability button, and then I make sure I hit this one, and then I type in a 6 and hit enter, and there's that 720 that we calculated just a second ago. So if you struggle with that on your calculator, we can sit down and take a look at your calculator, or you can call me and we can go over buttons on your calculator. Hey, or you could just Google it. That's what I had to do to learn about this particular calculator, but now I know how to do it too, so I'm pretty excited about that. But now it's not that big of a deal to do it by hand either. As a matter of fact, I want you to be able to do it by hand. The calculator is a way to check yourself and make sure you didn't do anything silly when you figured out your answer. Okay, so let's actually apply these permutations to word problems. So here's our first official word problem of the day, now that we've learned something new. And I went ahead and left the formula at the top of the page for you. And here we go. How many non-repeating 4-digit numbers can be written using only the digits 1, 3, 5, 7, 8, and 9? So again, 2 questions I want you to ask yourself every time you read a counting problem. Now, a counting problem, they all almost always start with how many. Okay, so first of all, what kind of problem is it? It's a counting problem. Next question is, can we reuse? If we can reuse, that means we can't use this new thing, okay? If we can reuse, then you're just talking about straight up multiplication principle. This number times this number times this number, where you need the tasks. If you cannot reuse, then you might be able to use this new formula that we have, okay? And, next, okay, can we reuse, and does order matter? Now, to be able to use permutation, there is no reuse, and order matters. Because a permutation is an arrangement. Just like the officers. So think permutation, think officers. Now in this case, how many non-repeating 4-digit numbers can be written using only the digits 1, 3, 5, 7, 8, and 9? Does order matter? You bet it does, right? Because the number, say, 3, 5, 9, 8 is not the same number as 3, 9, 5, 8. Right? If you rearrange the digits, then you get an entirely different number. Now, are we reusing? Well, no, it says non-repeating. That means we're not reusing, and we can use this formula. Again, no reuse, order matters. Good, we can use the formula. Now, when you use the formula, of course, you can write it as a P. Now, how many guys you have to choose from goes first. Notice I can use a 1, 3, 5, 7, 8, or 9. That's 6 numbers that we can choose from. How many are we choosing? 4. So we're doing a 4-digit number. So this is a permutation, 6, choose 4. How do we do that? Remember, the calculation is you do the first number as a factorial on top, and then in the bottom you subtract the 2 numbers, 6 minus 4, and the factorial goes on the outside. And then what do? I subtract next. So that's 6 factorial divided by 2 factorial. and then I say top number all the way down to the bottom one. 6 times 5 times 4 times 3 times 2 factorial divided by 2 factorial. Why? Because the 2 factorials will cancel. And then in my calculator, I just type in 6 times 5 times 4 times 3. Or if you like and you have found the permutation button in your calculator, you could use that as well. Either way, you should get 360. Now, knowing we went over that calculator button is important, but y'all, I will always calculate them, just in case you don't want to use that button in your calculator or you don't know where it is. Now, example C, we need to design an account number that consists of 2 numbers, followed by 3 letters, and then 3 numbers. It says if we are not allowed to reuse, okay, so no reuse. That bodes well for the new formula I just gave you, right? Because if you could reuse, you can't use this formula. So no reuse. It says no reuse the letters and the numbers within the groups, but we are allowed to reuse the numbers in the last group that appeared in the first group. How many account numbers are possible? It's like, wow. Okay, so we've got different situations going on. Okay, now how about this? What if we have task 1, which is select the 2 numbers? Task 1 is select the first 2 numbers. Task 2 is followed by 3 letters. It's going to be select the 3 letters, and then task 3, let's see, letters within the 2 groups. Okay, then 3 numbers. Okay, and again, we're not supposed to reuse the numbers in these first 2. We're not supposed to reuse letters in the second 3, and we're not supposed to reuse the numbers over here. But it did say it was okay to reuse these numbers in the 3rd group. So that means we're actually using the multiplication principle for these 3 things. In other words, we're doing this task multiplied by this task multiplied by this task. And this is when some of these problems get interesting, when you have multiple steps to do. Okay, now let's just look at the first task all by itself. So for the first task, what are we doing? It says 2 numbers. So how many numbers do we have to choose from? It just says 2 numbers, so how many digits are there? There are 10. So we have a permutation of 10, choose 2. Does the order matter? Remember, to use this formula, the order has to be important. And anytime you're doing a count number, order matters, right? 51 is not the same as 15. As far as an account number goes. So we have a permutation 10, choose 2. Let's move on to the letters situation. Now, how many letters do you have to choose from? How about 26? So this is a permutation 26 to, how many? 3 letters, choose 3. Okay, and then to pick 3 numbers at the end, and we can reuse from this list, which is good. It makes our life easier. Then we have a permutation of, we've got 10 digits once again to choose from, but this time we're choosing 3. Now, since these things are not being rearranged, the order, we don't have any duplicates in this situation. We don't have to divide by any duplicates. We just multiply these values together. So let's first calculate a permutation of 10, choose 2, right? So that's going to be 10 factorial divided by 10 minus 2 factorial. Now that's going to be 10 factorial over 8 factorial. I maybe should have wrote smaller, right? So I'm going to go over here and do this. This is 10 factorial divided by 8 factorial, which is really just 10 times 9 because the 8 factorials cancel. Are you okay with that? If not, pause it, write it out. You'll see. Okay. Now here we go. 26, choose 3. So that's 26 factorial divided by, subtract these 2, 26 minus 3 factorial. Now if I come over here to the right, because I'm lacking space, that's going to be 26 factorial. 26 minus 3, we know is 23 factorial. Hey, you know what that's going to be? That's going to be 26 times 25 times 24, because the 23 factorials will cancel. Again, if you didn't follow that, pause it, write that out like I was doing, 26 times 25 times 24 times 23 factorial. That 23 factorial will cancel with that one, and all I'm left with is 26 times 25 times 24. And then for the last calculation, when we select 3 numbers at the end, that by formula, 10 choose 3, so that is 10 factorial in the numerator, and 10 minus 3 factorial in the denominator. When I come over here and write this in blue, that's 10 factorial over 7 factorial. And when I multiply that out, that's going to be 10 times 9 times 8. Why? Because the 7 factorials cancel out, and I'm just left with 10 times 9 times 8. Now, I multiply this big list of numbers together, or I have found the permutation button in my calculator, and I just calculate all 3 of those permutations, and that's going to give me the answer to how many account numbers we have. So let me multiply this out and tell you what I get. Ooh, y'all, look at that big old number that I wrote. So let me circle it. Here it is. Now, what is that number? Let's count backwards. So there you have the hundreds group, there's the thousands group, and there's the millions group. So it looks like 1,10,880,000 possibilities for this account number. Of course, you know, the more places you have for an account number, this account number has 1, 2, 3, 4, 5, 6, 7, 8 different values, with some of them being letters, so you have even more options. The longer your account number, the more possibilities there are, right? So hopefully this made sense. Again, you're using permutations. What matters about permutations is you're not allowed to reuse the digits, which would give us even more possibilities if you could reuse the numbers, like 99 is not a possibility for the first 2 or the last 3. And if order matters, then you can reuse this formula. I mean, you can use this formula. You can reuse it too. Y'all, here's a really strange problem that I got out of the homework. I just grabbed it trying to give examples of homework that's in the textbook, and this is one of them. I don't believe that if I just threw this at you in homework that you would easily see what to do. I kind of had to play around with it. How many counting numbers have 4 distinct non-zero digits such that the sum of the 4 digits is? Okay, now it's really 2 different questions. So the first question, of course, is the D1 that I got here is 10. So what we're doing is we're using 4 numbers. So it says 4 distinct non-zero digits that the sum is 10. So I've got 4 numbers. Let's think about it this way. 4 numbers I'm adding together that equal 10. And it says non-zero numbers. So I can't use the 0 in this process. If I could, it would make this problem so much more difficult. So what I did is I just started playing with the lowest numbers that I know that are not 0. And it says, how many counting numbers have 4 distinct? You know what that means? They don't repeat. Okay, 4 distinct non-zero digits so that the sum of the 4 digits is 10. So if I used a 1, a 2, a 3, a 4, check it out. That just happens to add to 10. So there's no way I could do this with 5 included, right? Because if I did 1 plus 2 plus 3 plus 5, that's already too big. Or 1 plus 2 plus 3 plus 6. There's no other combination that's going to add to be 10, because these are the smallest numbers I'm allowed to use, and just by chance they add to be 10. Are you with me? That's what took me a minute to think through. So the only digits I could use is 1, 2, 3, and 4. Now, we could rearrange those, right? So really what I'm doing is a permutation. I have 4 numbers I can choose from, 1, 2, 3, and 4, and I'm going to choose 4 of them. And I'm checking the directions to make sure, yeah, it's 4 choose 4, okay? And 4 choose 4 is 4 factorial over 4 minus 4 factorial, right? And that's going to give me 4 factorial over 0 factorial. We know 0 factorial is 1, so this is really 4 times 3 times 2 times 1, all multiplied together. Now we know 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. So I contend there are 24 ways that you could do this. Now if you'd like to pause and think about the 11 question, it's the same idea. But instead, what you're trying to do is go through all the digits you know, 1 through 9. 4 of them add to 11. So play around with what you could possibly do with 4 numbers that add to 11. Now, have you thought about this one yet? So we still have 4 digits. They can't be 0. When we add them together, they must equal 11. Now, I'm not just thinking about any old random numbers, y'all. I'm starting small. So if I keep 1 and 2, you know, that adds to 3, plus 3 is 6. Well, we added 4 to get to 10, so to get to 11, can I just add 5? Yes, and if you think about, there's no other way that you could do this. If you work with bigger numbers, like 6 plus 5 already is 11, and we're not allowed to use zeros at all, and you're not allowed to repeat your digits. It turns out this is the only way to do that, okay? This is just picking my numbers. Now, the thing is, I can rearrange those numbers to get my counting number that is 4 digits long. So this is a permutation, once again, because order does matter. I can rearrange it and get a different answer. I have 4 numbers to choose from, okay, and I'm choosing 4 of them. Well, is that not the same calculation? Because I changed this 4 to a 5 over here, I still have 4 numbers to pick from, and 4 of them that I'm using at one time. So the number that we can do is 24. There's still 24 options. You could calculate it again just to practice using the formula. Permutation 4, choose 4. This 4 goes in the numerator, and then you subtract those 2 values in the denominator, this number minus this number minus this number, and then you get 4 factorial over 0 factorial. Well, remind me, 0 factorial is 1, right? And 4 factorial is 4 times 3 times 2 times 1, which gives us the 24. Exactly the same calculation we did. It's just that we're using different numbers, but how many of them exist is exactly the same. I'm going to wrap up this video here because I'm getting a little bit long-winded, but when you come back for part 2, we'll talk about something this time called combinations. And for a combination, it turns out the order doesn't matter. And I'm sure you can make up examples in your head where the order that whatever you're listing is in is not an issue. Not like taking a picture or creating an account number or looking at counting numbers, but what about just building a group of people together? That's when order doesn't matter. So come back for that.